Hello, good afternoon, everyone, and welcome to today's talk. This is our series, Let's Talk About the Future, from Lufthansa Systems, that we have set up to go into a lot of details about the urban air mobility movement, which is extremely hot at the moment. And I think most experts agree that this is in fact coming, and this is in fact coming very soon. One issue that we haven't discussed yet with regards to this urban air mobility topic, which is very close to our hearts, Lufthansa Systems being a vendor to the classic aviation industry, is the supply chain. And the question today is whether the supply chain is going to be equipped to foster the amount of support that all of these urban air mobility operators are going to need. And we're going into the supply chain with regards to scaling up vehicles, the supply chain with regards to putting these vehicles into operation, and all of these issues. We have today a great group of speakers and would like to introduce them to you in a moment. We are at Lufthansa Systems representing the IT arm of the Lufthansa Group and have a lot of products and consulting in the areas of flight operations, ground operations, network planning, revenue management, finance, predictive maintenance, as well as the in-flight entertainment that you have on board when you're in one of the aircraft for Lufthansa and the other airlines. As well have a daughter company specializing in data and artificial intelligence, and we support all of these IT products, implementations, and also solutions with the consulting arm, and this is where I belong. Today, as speakers, we have a great group. We're going to have a short speaker presentations, about 5 minutes for each speaker, and then go over into a panel discussion. We are extremely happy to have speakers every time we do one of these urban air mobility events, because we know the speed that this business is moving, and therefore the time of the people on this panel is extremely valuable. So very huge thank you from Lufthansa Systems and from myself. And without further ado, I think you already know him. He has been a speaker on our airspace event, but Parimal Kopardekar, PK, famous throughout UAM globally, I think now, with a constant presence, and he is leading the NARI part of NASA, which is the NASA Aeronautics Research Institute. So welcome, PK. Thank you for being here. We have then Dana Jensen joining the panel and making a little talk for us to introduce himself. Dana is with a background in Wall Street with the financing and the ability for all of these companies to become successful and to have the resources that they need, from good idea to an actual sustainable business. Within the US Air Force, and he is joined the US Air Force a couple of years ago. So welcome, Dana. Thank you for being here. Then we have from Hyundai Motor Group, we have Adam Slepian, and Adam is looking after the entire UAM partnerships from their UAM division. They are looking at manufacturing, but also looking towards becoming a multimodal mobility offer for the global markets, specializing on a couple of key markets at the beginning, but definitely with global ambition. So looking forward to talking to you, Adam. Then we have from Rolls-Royce, who's heading up the UAM business unit there with all of the electrical powertrains and all of these topics, Gabriele Teofili. So Gabriele, welcome. And last but not least, we have my CEO, Olivier Krüger from Lufthansa Systems, joining us from Munich. And welcome, Olivier. My name is Erin Beilharz. I am a consultant at Lufthansa Systems and have been delving very deeply into the urban air mobility topics for about a year now and have discussed a lot of these burning issues with regards to supply chain with a lot of the operators and suppliers as well. I would like to turn over to you, PK, if I may. And
yeah, thank you. Thank you, Erin, for inviting me. Hopefully you all can hear me. It's a very good morning from the Bay Area, San Francisco here. So I am here to quickly chat about the advanced air mobility and the need for supply chain, what we have learned from the previous supply chains of aerospace and how we can make sure that we set up the supply chain for advanced air mobility right from the beginning. That's one of those things that we need to start thinking as in a proactive manner rather than a reactive manner. Next slide, please. It's great pleasure to be with the distinguished panelists here. So I would like to share a few thoughts. The first thought I have is there are 3 stages of supply chain which are very critical, and understanding of those are important from the perspective of setting up the sustainable system. In the beginning stages, when we are still doing vehicle prototyping, pre-certification largely, smaller quantities is what we go after. So we really need access to the suppliers at the early design iteration. So we're not looking for high volume, but we are looking for rapid design changes. Those suppliers tend to be sometimes different than the high volume manufacturers. So access is very important, and we'll talk about what we are doing to enable that access. One of the goals here is to also bring more suppliers into the aerospace system. As aerospace system is growing, there are reasons why we need to have more suppliers so that we can maintain the resiliency. That resiliency really comes when you have a production certificated vehicle and now you are successful and you're starting to make hundreds to thousands of vehicles per year, roughly. At that point, you don't want to depend on single source suppliers because of the many risks that it carries. I mean, there's a lot of textbook material on risks about supply chain and resiliency, and we saw many of those during COVID as well. So resiliency start to become important aspects. So continuity of business, conformance to quality. So you tend to have multiple suppliers for critical parts. So that's sort of the stage where you look at how do you maintain the resilient operation. And we'll talk more about that. And the last part is the scalability. Now you're very successful. You're building aircraft or any other vehicle, cars in millions, drones. How do I maintain the access to the suppliers, maintain the resiliency, and maintain the high production rate? At this stage, you also start to worry about MROs, maintenance, repair, and overhaul. What is unique about urban air mobility, advanced air mobility, is that the needs for MROs are going to be very localized or regional level. So we want to have parts inventory, we want to have access to maintenance, technicians. So that becomes very critical that we set up those systems right in the beginning as we start to get to the scalable needs. So next slide, please. So very quickly, access will be basically provided through electronic exchange platform. There are many companies out there. We are also offering one to reduce the friction for small and medium-sized enterprises to join so that OEMs can find them and the small medium enterprises can find OEMs. So it is really B2X play from B2B, which happens to be the way it works today. So reducing the friction is the most important thing at this point. Next slide, please. Once you kind of got everybody going into the platform, then we really would like to, where we are headed is the digital supply chain network, or digital twins, some people affectionately call that. The idea is all supply chain tiers, all the way to the raw material, are on this system for the entire ecosystem. So you can do your transaction. You can also get aggregate demand planning together with multiple OEMs, and multiple OEMs have access to multiple suppliers for resiliency. So we can start this as a minimum viable product and trace parts and trace contracts and trace design changes, any capacity changes, real-time dynamics. This is very critical to maintain that throughput that is needed to get to that scale that we talk about. Also is needed to maintain the parts provenance tracking, which is sort of making sure that we have the right type of parts that are authenticated, the people who are actually working on those maintenance repair overall are the right ones. The ones who are using in the design stages are also right ones. So lots of interesting dynamics here in the entire network. Next slide, please. Last one is modeling and analysis simulation kind of capability, where if you say as an entire ecosystem, we want to build 10,000 eVTOLs in 5 years from now, 3 million drones. I want to build 1,000 Boeing type aircraft, 1,000 Airbus type aircraft. I want to build another 1,000 helicopters and general aviation as an industry at large. The question then comes is, do we have enough capacity in the ecosystem? Am I going to be basically tapping on the same suppliers that electric car companies are doing, for example, Cobalt? If everybody is going after the same source, then we create a bottleneck. So at that point, we really need to start look farther out. We already saw some examples of microelectronics when it was not available. Companies had to shut down their operation. We can't do that if we want to have a scalable and maintainable, basically sustainable supply chain and operations as well as the organization. So the goal is to have this analysis capability that we can continuously assess whether we are capable of meeting the growing needs of this ecosystem. What is important there is that supply chain doesn't happen overnight, so it does take some effort, and we need to have, as an aggregate level, we need to have a system, because what happens, individual companies have those analysis capabilities, they do their own analysis, but what they may or may not know is they all depend on the same casing manufacturer or the same battery provider, because there are regulations by which they avoid talking to each other about their suppliers. But then as an ecosystem, we need to find out these gaps and overlaps. So last slide, please. And this is the last thought I will leave with you, is that we really need to update our curriculum, foster workforce. We already see potential, basically weakness in the high voltage technicians. We already have seen aerospace engineers are in high demand, and a lot of companies going after top talent, and they're taking one company to another and they kind of keep moving. Instead, we need to sort of organically build this, and I think it takes time. And we need to push significant push towards Aero, making it Aero an exciting career and building more entrepreneurs inside Aero. So that's sort of where we want to see more things change, so that there is going to be a supply of the workforce as well. Next slide, please. So I'll quickly summarize. I'm really excited. They said we had to talk about 4 steps, what we do. So we do basically research, NASA Aeronautics Research Institute. We basically want to see that the supply chain is more resilient. How do we plan to contribute? We plan to contribute with basically a working group. You will see Dana and I co-lead a working group in terms of how all collective supply chain folks can be part of this. We can set the standards right. We can collaborate with each other, bring in new businesses, identify opportunities to grow. So fundamentally, we need more suppliers to join ecosystem. We need to reduce the lead time by digital transformation. We need to train more people. We got to get more capital going, particularly lower tier suppliers. You see a lot of capital flowing at OEMs. It's also important that the low tier suppliers are healthy, that they need to have capital, and there needs to be a tighter coordination for demand aggregation as well as changes that happen at the capacities up and down the tier of suppliers. So that's sort of my thought. Last slide just talks about our work group. Please join our work group. We have a vibrant work group, and you will be able to basically engage with the work group members, discuss ideas, opportunities, take advantage of the networking. This is sort of one unique supply chain work group that is focused on advanced air mobility that Dana and I manage. Send me emails if you have any thoughts or anything you would like to see us done differently. But look forward to having your participation, and thank you for the opportunity.
Thank you, PK. So interesting. Thank you so much. Just as last time, learned a lot from your short talk. I have a little question for you to follow up on this, and that is, you just mentioned the reaching back into the same supply chain that the automotive companies are reaching back into, and that the bottlenecks will be there. For any of us on the talk today, any of the audience joining from automotive supply chain, what kind of learnings would you bring from the aviation supply chain with regards to certification, and how far back into which tier did they need to be affected with regards to what kind of products need to be certified for aviation?
Yeah, that's a great question and a pretty long answer for that. But one thing that I would say is production certification is something that the OEM has to have, and the OEM can qualify the suppliers. I'm not a regulator, but I can kind of offer things from what I understand. The OEM has to basically get the certification for the entire supply chain. Individual suppliers can also get certification, for example, ball bearing or battery or magnets and such, and that can be used by other OEMs or number of OEMs. So there are a number of ways you can do that. This is a very important consideration that if you want to enter into the aviation aerospace, the reason that is important, there are different liabilities, there are different underwriting requirements that OEM will ask you, there are different temperature and forces requirements, and then it could be some give and take obviously between the suppliers, because suppliers have a pretty good knowledge of what's easy to manufacture, which is the good design changes that you need to do. So that give and take happens in big companies like Apple as well, and I think it's very important that that give and take start to occur in our industry as well. So this is a good and important question. Thank you.
Okay, perfect. Thank you. I'm going to hand over now to Dana Jensen. Dana, go ahead, please.
Well, yes. First of all, thank you to Lufthansa Systems. Thank you to Katrin and Erin and Olivier for your time. I think this is an important topic, and as you'll probably see going forward here, you'll see a lot of commonality between the points that PK and I will make. That's because we spend a lot of time, obviously, coordinating our thoughts around the advanced air mobility supply chain working group, which we've had for about 8 months now. We have over 400 members. So yes, echoing PK, please do join. And I think I probably stole a couple graphics of his in my slide deck here. So please don't think that we're plagiarizing. We just have good alignment here. One thing I will say is, in the panel discussion, I would like to sort of foot stomp the human capital idea, because that is going to be a big potential bottleneck, and one that's maybe not as easy to fix as some of the technological hurdles that we might see. Most of you are probably familiar with Agility Prime. I'm not going to belabor this slide. I know there are a lot of words on there, and that chart, it took me about 30 minutes of staring at that chart to understand what it was trying to tell me. So to the extent that this deck is available after the fact, you may want to take a look at this and stare at it for a while and see if you can make sense of it. But suffice it to say that the Air Force has a very strong interest in fostering the commercialization of advanced air mobility. The idea being that, normally we would procure things based on a set of predefined requirements, right? And we would take them to Lockheed or Northrop or Raytheon, and we would say, hey, can you build us one of these? And so if we were to come with requirements for an eVTOL vehicle, for example, we could hand those to one of the prime contractors, and they would say, sure, we can do that for you, no problem. But we may not enjoy the economies of scale that would be available if we were to go via the commercial market, right? So we're trying this as an experiment of sorts to say, we're going to do what we can to foster the growth of this industry on the commercial side first, and then come in after it's scaled and do our procurements, because we can take advantage of that economy, the pricing, and also the fact that these things are probably going to be a little more cutting edge because they're competing with each other in the commercial market in a way that doesn't necessarily happen in the traditional aerospace and defense market. So it's a novel approach. So far, it's been working very, very well. In fact, we're planning to roll this methodology out to a number of different topic areas. But the way that we do this is not necessarily by writing huge checks. It's by giving these firms access to wind tunnels and test ranges and anechoic chambers and environmental chambers and test pilots and test planners and airworthiness people, capacities that are not necessarily unique to the Air Force, but that we can provide at no cost, right? And if they were to go out and try to book commercial wind tunnel space, it could be cost prohibitive in some cases. So we're trying to use this, what we call in-kind support, to foster the growth of industry. And so far it's worked very well. Next slide, please. This is just a plug for the supply chain working group. We've already seen that, so go ahead to the next slide. Okay, so broadly speaking, what our supply chain working group is trying to do is, number one, understand the current situation as the supply chain emerges, and understand with a kind of a snapshot how we can reduce the friction in the interaction between OEMs and suppliers, and between suppliers in different tiers. And so what that means is we need to understand how this supply chain is emerging right now. So it's a little more in the weeds than the next step. The next step is the modeling and simulation that PK was describing, where we're actually trying to say, okay, if someone walked into one of these OEMs and ordered 10,000 of them, can we do that? Can we meet that demand? And if not, where's the fragility in the supply chain, right? And so that's driven by data, and that's ongoing now, and we'll in the coming 6 or 12 months start rolling out some preliminary analysis that we've done. But what I focused on in the short term is, where do we stand right now? And so this laydown, for example, and again, it's inherently incomplete. And one of the things that I try to do is say, look, I'm going to put this out there knowing that it's not totally complete, because then I can say, hey, look, if you want to be on here and you're not, please raise your hand and drop me an email. And as we do this, we iterate and we get better, right? We have a more subtle understanding. Well, Lufthansa is on there under infrastructure. The big question is, a lot of these firms, like some of the tier ones especially, could easily exist in half a dozen different boxes here. The problem is, if we try to do that, we're going to get overly crowded, and also there's a limit to the number of hours I have in the day to do this. But Lufthansa is a good example. It could just as easily exist under safety, right? And anything to do with training, and you could say consulting. I mean, there are a bunch of different cross-cutting ways that we could do this. We just kind of made the arbitrary decision to say, okay, pick the box you are most suited to, because otherwise we would get a lot of repetition, and maybe down the road we'll have the bandwidth to do that, and that would make more subtlety available to how people are spread across the ecosystem. Anyway, so this is kind of what we see right now, and what I'd like to do is kind of drill down on one potential bottleneck area as an example. So next slide, please. So electric motors. And Rolls-Royce, will be part of this too, is a potential bottleneck, because as PK mentioned, and I don't want to use the word competition, but I'll use the word competition. We are competing for raw materials, resources, manpower, and market share in this area with the automotive industry, right? Because automotive, we are dwarfed by automotive in terms of the scale that we're looking to build. So how do you get the attention of motor manufacturers when they've got a business already, building 8 million cars a year, to say, hey, would you mind also helping us out at a much smaller scale with a motor that needs to be optimized for weight in a way that they don't necessarily prioritize? And so in some ways there is a competition for bandwidth and for attention. And I've noticed in talking to these firms that sometimes it's the mid-tier firms that are more willing to go all in on advanced air mobility, because they don't have a big revenue stream already in, say, automotive or industrial applications. So that's an interesting dynamic I don't think we would have predicted ahead of time. So anyway, these are some stats just about kind of the numbers that we would need to achieve, and the sort of power and energy density that we would need, that we believe we need in talking to the OEMs, and this idea that ARPA-E, with the Department of Energy's advanced research arm, has said greater than 12 kilowatts per kilogram is really where we start to get viable with larger aircraft, and so using that as a benchmark, we can start looking at some of the other some of the motors that are already out there, right? And I also would flag the second point from the bottom, which is to say, hybrid systems are delivering huge amounts of current, especially things that are hybridized with turbines, right? You're talking about, over 2 megawatts, and there isn't a lot of available componentry in terms of power electronics that's capable of handling 320 amps or operating at 800 volts. Those things are available for industrial applications on the ground, but weight optimizing wiring and relays and those sorts of things and switches for those sorts of operations in an aviation context is sort of a challenge in terms of sourcing. And as PK said, the human capital, the technicians that know how to work with these sort of current loads is also a shortcoming that we'll need to address. Next slide, please. So this is just a kind of a snapshot of, you know, if we were to take a square out of that bigger laydown and look just at electric motors, you know, these are the major players who have come to us or publicly expressed an interest in being involved in advanced air mobility, right? And there are a couple of other firms, these enabling firms, who work in, you know, additive manufacturing of parts or machines that do motor windings, or Halbach array magnets, right, which is an advanced arrangement of permanent magnets, which could help enhance power and energy density. So that's, you know, again, this is not exhaustive, and in some ways it's meant to provoke other entrants into saying, hey, we would like to be in there. But, you know, we've seen these firms either sign on in partnerships. You know, I think Denso and Honeywell was just as early as this week to say, hey, you know, we are involved or want to be involved. And, you know, MRAX has already had a history, and Magnix as well, and YASA, of course. And so, you know, these are all firms that are at sort of the leaning forward toward advanced air mobility. They may have traditional business like Rolls-Royce, but have made a commitment to developing advanced air mobility specific technology. And it's something obviously that we believe, in looking at the landscape, is sorely needed and welcome, right? And then the chart below is just sort of a breakdown of, you know, how do you compare the performance characteristics, you know, the peak versus continuous power and power to weight ratios of various solutions that have been out there. And I also included a couple of automotive, a couple of, you know, just other, for comparison's sake, other applications. And the data is not complete. Not everyone is publishing continuous and peak. But, you know, this is just to give you kind of a general idea. And again, anyone who's watching today, who's involved in this and sees flaws in the statistics here, or that they've changed, please do let me know, because we want to keep all of these presentations as sort of living documents that reflect, you know, that iteration that we're trying to do to understand where we are now, and then we can feed this into the modeling of, you know, where would potential bottlenecks be in the future. Okay, well, let's leave it at that. Given our short time constraint here, and we'll circle back and talk in more detail during the panel. Thank you very much.
Absolutely. Thank you, Dina. Wanted to follow up with a small question with regards to, you mentioned that all of these companies supplying potentially aviation, avionics companies supplying automotive are all coming in. It's difficult for them to come in potentially when it's at the detriment of their current production facilities or things like that. Which are the companies who you have not seen enter the UAM market, where you're kind of missing them and would like to give them a little nudge? Or are there any kind of...
Well, I don't want to name names, because I know some of them have, for lack of a better term, stealth efforts. You know, they're working on it in a low-key way, and they're not really disclosing it because they're not necessarily sure that they want to do it. I mean, there are some pretty big existing defense contractors who are missing from this, and you're like, well, why aren't they in the space? And the short answer is they're being cautious, right? A lot of them have revenue through traditional defense contracting routes, and so they're saying, look, on the side, we're working on this, but we're waiting to see if this is real before we dedicate the resources. And I will say, I think there are some firms out there, you know, who have the resources to do sort of a sprint, you know, a breakout, once they see that this is going on, and they can come into market, you know, gangbusters, even though we haven't really heard much from them up until now, and they're just sort of biding their time and assessing the market. And so, partly because they're a little more risk averse because they've already got revenue and they've already got relationships, and they don't want to jump into this until they see that it's real. And so to that degree, I really applaud those who have done this, right? And I would say primarily in the automotive industry, they've made some pretty big bets and they've made some big commitments, and Hyundai being one of them, to say, hey, yeah, we're committed to this. We're not necessarily going to commit to a really aggressive timeline, but we are, the numbers we're putting into this and the manpower we're putting into this are reflective of the seriousness with which we take this. And so, on one hand, yeah, there's some people who are missing who I won't name, but I will, hats off to those who have come in, and we hope you stick with it.
Yeah, thanks a lot. Moving on, I think that's a good segue for Adam Slepian from Hyundai to get into a little bit of what they're doing. Adam, go ahead. The floor is yours.
Thanks, Erin. And good morning, good afternoon, good evening to everybody out there. Erin, Olivier, thanks for having me on. Dana, thanks for the shout out. Appreciate it, as always. Great to be on the panel with everybody, and looking forward to an awesome discussion today. I'll jump into a quick, really quick overview of what is Hyundai doing, why are we in the space, to Dana's point, and then really dive into some of the intricacies that we see to the supply chain aspect. So Hyundai, most people see Hyundai as a car company through and through, but Hyundai Motor Group is much, much bigger. It's a major global conglomerate. It's really been at the forefront of innovation since it started back in the 40s. With our founder, Chung Ju-young, we actually started as an infrastructure company, a post-World War II redevelopment company in South Korea. That went into the 60s and 70s, building ports, highways, et cetera. And it wasn't until actually the 60s that we became what most people see Hyundai as today, as a motor company, an automobile company. Continued to innovate in the 70s, became South Korea's first mass-produced car, innovated on supply chain, innovated on manufacturing. And then also innovate on the customer aspect. Something that is really important to us is it's not just the solution, it's not just the technology, it's not the supply chain manufacturing, it's dealing with our customers, the people that are going to use our products and our services. We look at 1999 released the industry's best automotive warranty, and that continues now into the 2010s and into the present. Successfully tested autonomous vehicles, and we're continuing down that path on the ground. Alternative energy solutions, hydrogen fuel cell development, major aspect of Hyundai Motor Group. And then last year in 2020, right before kind of the world started to shut down, unveiled our SA1, our concept vehicle at CES, and the move into air mobility. So continuing to innovate across mobility solutions, mobility devices, electrification, hydrogen, and serving customers more broadly. And we'll get into that here in a second. So with that, we're making a long-term commitment to develop the UAM space, like Dana actually just referenced, right? This is going to take a long time to be able to build this at scale, and we're committed. We want to have it part of our overall vision of human-centered cities, leveraging innovative mobility solutions, both the services and the technology. And really at the heart of this is to make this a scalable solution, a mobility solution for the masses, right? You'll hear us say democratize flight. As this progresses and it scales, we want universal mobility services that are first and foremost safe, without question, and then affordable and efficient for everybody to be able to get a ride in the future. How does that come together? It's part of our overall vision, and our chairman, Yu-Sung Chung, the vision is much greater than just UAM. So everything we do, even at the UAM division, of course, we're doing to advance the air mobility side, the advanced air mobility sector, urban air mobility sector, but it's with this whole integrated multimodal solution in the back of our minds. It's from the urban air mobility vehicles and the purpose-built vehicles and autonomous vehicles, semi-autonomous vehicles, electric vehicles, hydrogen fuel cell vehicles, et cetera, and then coming together in the infrastructure to pull all this together in and around cities moving forward in the future. What does this kind of really look like at the end of the day? Working with our elements at Hyundai Motor Group and our external partners, we envision this really multimodal, seamless journey. For example, I'll pick on Dana a little bit. Dana, at some point in future, you're going to be able to, go on your phone or some other type of device, get into an app, click a button, and have a seamless journey, right? It integrates that multimodal solution. It matches you with the right vehicle. It matches you with the right route, and you don't have to do any of that legwork, right? You get to a vertiport, you go through security very quickly and safely and efficiently. You get on an aircraft. Very part of the seamless journey is you got to be able to get on the aircraft quickly, because this is about saving people time, right? It's about giving people time back in their day, and saving them hours potentially in a day through being able to transit in and around cities. Get on the aircraft, you have a smooth transition. Part of that human-centered approach and that user experience approach is the aircraft has to function flawlessly, right? People don't want to get in a ride, multiple times a week that's going to have a turbulent transition between takeoff, vertical takeoff and landing, and the transition period. And of course, onboard amenities, and then you get into that last mile, right? Maybe you get in another PBV, you get in another ground-based vehicle, maybe you just walk, right? Because we can get you close enough to where you need to go. But it's all part of that journey to give people back time in their day and allow access and placement for people through mobility. Mobility in historically has been a limiting factor for progress, and our vision of progress for humanity, we want to be able to fly over that in many regards. But why are we here today, right? To make all of this reality, it all kind of comes down to the supply chain, in my very humble opinion, and I think a lot of folks on the call today would agree. To make this reality, we're deeply focused on this, not only across Hyundai Motor Group, but with our external partners, both in the private sector and of course the governmental and regulatory sector, right? With the Air Force, with NASA, with regulatory bodies like the FAA and EASA. This is really important to be able to pull all of this together. We really look at this holistically. A lot of people think sometimes supply chain is just go buy some parts, right? Put them in a vehicle, put them in an aircraft. It's easy, right? It's one of the most challenging aspects of this whole thing to be able to bring this together and do it at scale and do it at the right cost point to keep utilization of the aircraft up and do it safely, right? We look at this in kind of three major buckets, so to speak, right now: procurement, manufacturing, distribution and other logistics, and MRO and other services. I think a few things that Dana and PK had already mentioned, right? And for us, it's all about pulling all of these things together with our internal and external partners within Hyundai Motor Group and outside. Because it's about the life cycle of the entire product, and it starts with the planning phase. It goes all the way through the usable life of the equipment or the product or the service, to bring all of those aspects together. I'll start with procurement and manufacturing. How do we do this, right? At Hyundai, we have decades of experience and scale in procurement and manufacturing. It's one of the areas that the automotive sector brings, right? Design to manufacturing. How do we integrate that into our aircraft design, both things on the vehicle and off the vehicle, to be quite honest, because we're working on things off the vehicle as well. Leveraging the scale that Hyundai has in terms of procurement, right? We procure billions and billions of dollars things a year in the mobility space. Designing the manufacturer, working with our manufacturing teams here, both in the US and abroad. Recently broke ground on the Hyundai Motor Group Innovation Center in Singapore, right, for the future of smart manufacturing, and work with them, and also work not just internally, but how do we take that aspect to our external partners as well? How do we bring our scale for something we may not be making, that we may be getting from an external partner, but how do we provide our scale from procurement aspects into that, if you think raw materials or other subcomponents, et cetera. Switching over to distribution and logistics, right? One of the fundamental issues in the UAM space, especially for eVTOL, how do you get the aircraft from point A to point B when they come off of final assembly, right? It funnels back into that design, the manufacturing aspect of the supply chain is integrating in that to make sure that we can get the aircraft from point A to point B after final assembly to where they need to be for a customer or an end user. Hyundai, we're fortunate enough here to have Globus. It's our global shipping and distribution company, and integrating with them to make sure that we get the designs right, that we get the operating model of that right, both from the aircraft itself and all of the aftermarket parts that we're going to need to get from point A to point B, consolidating that logistically, warehousing, ordering, tracking, et cetera. Leverage the existing networks that we have in place, and also be able to bring our external partners along for that. And then last, MRO and other services. This is that long tail of this entire operation that I think PK had mentioned as well. Integrating that from a automotive perspective, it's not the full solution, right? There's differences clearly between automotive and aviation, and there's a challenge, especially from a regulatory aspect, and a certification aspect, product and type certification, of course. But how do we pull things like MRO together? It's a very interesting aspect you brought up, Dana, on electric motors. Electric motors is where a lot of the world is going, obviously, for automobiles and for aircraft. Why can't we have Hyundai certified mechanics working on electric motors for ground-based vehicles? Excuse me, as well as aircraft, right? As long as there's essentially a shop supervisor, he or she is certified from an aviation perspective, you can really potentially do both, right? So we got to think innovatively. We got to think creatively of how do we bring these things together? And that's just one example of kind of a million that are out there. And not all of them will work, right? And we realize that. But how do we find those examples where we kind of we bring this together to leverage the innovation that you see in automotive, that you see in aviation, combine the supply chain aspect, and it's not just, again, it's beyond the parts. It's not just buying a part and getting it into something. It's that whole long tail of supply chain and logistics from design to the end life of that piece of equipment, and bring all that together. And that's why working with our partners both internally at HMG, we're very fortunate to have that. And then, of course, with our external partners that we're developing, and folks like Dana and PK and other folks that are on the line as well. So really excited to continue on the discussion today and take questions, and excited for the future of mobility and UAM being a big part of it. Thanks.
Thank you so much, Adam. That was fantastic. Just have a little question for you getting off the ground. How would this split between educating aircraft mechanics and car mechanics work? Have you fleshed this out? It sounds like you've done a little bit of thinking on this topic. How do you imagine that would work? And if universities are in a position to start training people, when do they need to be ready, and how many?
Yeah, that's a great question, Erin. So we are taking a look at this. We're also taking a look at this through some existing partnerships we have, for example, in Los Angeles, and we're trying to develop that from it's a workforce development question, essentially. And we think that's really important, and we're going to be putting a lot of time and energy into that, right? If you don't have that people component of it, and you don't have it kind of in a massed effect in the right areas that you're gonna, start to try and develop scale from an operational sense, you won't be able to do it, right? If you don't have the maintainers, and you don't have, well, A, you have to develop the program. B, you have to get the right people. You have to get them into that program, so you have to incentivize them in the right ways, right? And that's kind of the people side of it, and the org development side of it. And then you got to put that into practice, operational. It takes time to train folks. It'll take time potentially to switch folks over from, even if they are trained in it from the automotive perspective, to be able to add on a credential, for example, to aviation, right? But that is definitely one of the approaches that we're looking at, and we've started underway with that in some specific geographies. But it's going to take time, right? But also, we have, what we stated, obviously, our entry in the service is 2028. It's a little longer out. It's about 7 years from now, right? But that time is going to go like that. It's going to flash by. So that's why we're starting on those things now, working with our partners internally, and then expanding that externally to go develop those programs and make it happen.
Thanks a lot. I forgot something very important at the beginning of the event, and I apologize, but to the audience who's watching, please, if you have any questions for these guys or for us, there is a little icon. It's kind of a chat function with a question mark in it. This is the Q&A function, and please send the questions over and I'll get them answered for you either after the talks or in the panel discussion at the latest. Okay, thanks a lot. Handing over now to Gabriele from Rolls-Royce. Gabriele, looking forward.
Thank you, Erin. Thank you very much, and thank you, Oliver and Lufthansa Systems. I think from my point of view, it's an incredible opportunity to be invited to this panel. There are a lot of very nice hints for all the part of the supply chain, and being in the supply chain discussion today for the urban air mobility after I started thinking and working in the electrical aviation in 2012, which is not very long ago, but it was the pioneering time of the electrical aviation. It demonstrates the speed this war and this environment is having. So thanks a lot for that. let's go to my first slide, and I'm clarifying why Rolls-Royce, one of the few, I would say, aerospace giants I saw on the chart of Dana, is willing to go in this environment. I have a single word here. We want to champion the electrification of aviation. So Rolls-Royce is part of the supply chain for the OEM and for the final customer as a supplier for the full propulsion system. It's very important to understand there are a lot of supplier of electrical motor, which is one single part on the electrical propulsion system, and there are few suppliers which offer subsystems like the battery energy storage or propulsion unit. We want to champion the electrification, offering a full palette of systems. So Dana, thank you for calling us bottleneck. It's incredible because the bottleneck, from my point of view, I always look at the positive part. It's an opportunity. So we need to enlarge the bottleneck problem, and we want to do it with a pedigree of experience, with a very pedigree of knowledge in the aerospace, but we cannot do it with the old speed, with the old approach to certification, with the old approach to time schedule, which we are master of in the aerospace. And I speak for Rolls-Royce, and I speak for our customer and suppliers, our existing supply chain and our existing customer landscape. So how do we do that? We enter in the new world with new approach, having an experience at a pedigree from aerospace. Let's go to the next slide, please. It's not a slide about ideas and diagrams of the future. This is a slide about hardware, facts, demonstrators which we have produced so far. So we don't speak about being the pioneer of power and mastering the electrification as an idea. We have demonstrated Rolls-Royce Electrical in this case is able to demonstrate the capability of deliver according to the timescale of the new urban air mobility expectation, to demonstrate that the system work together and to demonstrate with flight tests of demonstrator and prototypes that the system works. Sometimes in some panel discussion, I say the hardware is there. We have to bring it to certification, but the opportunity is there. Sometimes it's the infrastructure which is missing, or the full chain. That's why it's a very good opportunity to be here today. So a couple of words regarding each of these examples. They are all equipment which we don't develop anymore because we have tested them, we have learned from them, and we are entering already in the next generation. So we can see from left to right the 200 kilowatt model, which is powering the City Airbus demonstrator. We can see the so-called EPU-3, which is a full propulsion unit system, which flew with the Magnus aircraft for several years already in the last time in Hungary. The Blio-2 V2 battery as well, completing the propulsion system for the Magnus aircraft. We have inverter prototypes, we have power distribution prototypes. We have learned from experience, and we have used novel technology and novel components based on a pedigree of aerospace, working with people which know how to deliver components on time to aircraft manufacturers and how to bring this type of components in the sky. That's why we are, I would say, honored from one side, and also excited to say we want to become the leader of this part of the supply chain. Next slide, please. So this slide looks a little bit about me, but you have to see the picture. So I like to bring facts from what we do. I was working in Leonardo helicopters, Airbus helicopters, and now I work in Rolls-Royce Electrical, passing by Siemens e-aircraft, of course, which was acquired by Rolls-Royce Electrical in 2019. And PK was speaking about the lack of aerospace engineering today. It's a very good news for me. I studied aerospace engineering in the 2000 years, and we have always the idea. Did I select the right address in my university? Of course, we are following our passion. Aerospace cannot be just selected because there is a nice job in front of us. Aerospace is passion, and when you see this picture, you recognize the last picture on the bottom. This is the picture of the City Airbus Alpha demonstrator. It's one of the most complex, I would say, demonstrators we have on the landscape, and it looks like the other two pictures as well. So we are changing the aviation but we need to have the knowledge of what was done in the last 100 years in order not to commit the same mistake which were already done and corrected by the normal aerospace companies. That's our believing. That's why we are collecting aerospace know-how in our company. We are bringing insight, like PK was telling, electrical engineers. Of course, electrical engineers were working already for the aerospace, but not on that level and not on that responsibility, delivering the power which will carry the aircraft in the sky and having this responsibility. So we are responsibilizing them and let them become the new aerospace engineer of the future, let's say. We need manufacturing technology. It's a totally different approach, transforming a design from the aerospace standards we have in manufacturing reality based on novel materials and the same certification requirements, for example. Most of the certification requirements we are reading today in the special condition, in the special condition VTOL and E19 from EASA are coming as well from the know-how of EASA. So we need to understand how they were written, how to demonstrate the compliance against these requirements in order to speed up. Because we know that the schedule of the urban air mobility, the schedule of companies like, for example, what Adam was speaking about, Hyundai entering in the world, they are very challenging. And Rolls-Royce, from one side, has the capability to know what is needed to be done in order to get certification. From the other side, had demonstrated the possibility to deliver and demonstrate in flight very quickly eVTOL propulsion unit components. Next slide, please. So a couple of slides, a couple of information about top challenges. If we click here, yes, maturity of the hardware. Yes, I spoke about demonstrating in flight the capability of install hardware of a novel technology in old, or let's say platform which are traditional. The idea of selling a smarter, so more interconnected, delivering information live to a cloud or being connected with a cloud in order to verify maintenance and repair capability, to have a cleaner system, so which is not producing pollution, but in the same time having a robustness of 70 years of development and safer propulsion system, it's all what we call maturity. So the maturity is reached by delivering prototypes, testing prototypes, and having a continuous background of testing in our laboratories. That's the way we are approaching a level of maturity of the hardware, which will accompany the certification activity and bring us to type certification of the propulsion system and accompany the OEM in certifying the whole vehicle. We need to have a new approach in terms of propulsion units. So it's we were speaking about requirements. Of course, the aerospace engineer is fed every day lunch and dinner by requirements. There is a new approach to requirements, not interpretation, I would say, but management. We need to sit together with the iframer and discuss the best system for the custom solution together. Then I was speaking about power to weight ratio, for example, torque to weight ratio. I like to speak about torque to weight ratio because working in the eVTOL, you need to deliver torque to lift instead of thrust for cruise, for example, or both of them in the new configurations. And in order to have the best system and enough payload to demonstrate the capability of demonstrating this business case and having profitable solution, we cannot just think about the best power to weight ratio of the single motor. We need to have a full integrated system and to be developed together with partners. In this case, I'm showing the picture of Vertical Aerospace, which is partnering with us for the development of the X4. Where we can speak at the same level. The architecture of the propulsion unit cannot be divided from the architecture of the vehicle. So this full engagement, this working as a supplier in the supply chain, but in integrated way with the customer is a key solution to solve the problem of delivering payload from my point of view. And of course, I already mentioned several times certification complexity. It's a complexity because the system is new and we are discovering nowadays what is happening once we repeat the test we have already done several times with the traditional components. And the idea to approach together with the civil aviation, for example, the authorities and the airframers, the new way of demonstrating the same level of safety we had in the past is the way to solve this challenge. I will add one word here. Everybody's telling me we have to be smarter, leaner, more agile. We have to forget the old way of certifying components and approach the certification authority with a new way. Well, I answered them. I expect this type of components to be more safe than anything else which is flying, because they are going to approach ourselves very, very close to our apartments and houses and our children, and I want them personally to be safer. So I don't think that faster or different it's a negative adjective. It has to be safer as well. And yes, the cloud is appearing now. If I had a wish, I would say, I think I demonstrated in this 5-minute speech that for my point of view, the competence in the aerospace, the competence in the electrical technology, the competence in the automotive supply chain for this upscaling, for example, is very important. And professional deontology is one of the important milestone or let's say pillars we don't have to forget. I cannot believe I'm going to have a less, let's say, level of safety for anything I'm doing in order to make something fly closer to my family. So I need to be competent, I need to be safer, I need to be faster, but also remember that for an engineer, the professional deontology is a must.
Fantastic, Gabriele. Thank you so much. Just wanted to take up on a point that you made with regards to the City Airbus project. I was wondering if there was anything coming from your helicopter background, from design phase through to prototyping phase, anything that went much more slowly, much more challenging than you thought, if there was any kind of things where you had surprises that came up when you tried to put the hardware together, which was in fact more difficult than you had imagined?
Well, I don't remember anything which was low in this project, so I have to answer in this way. But I must say what we have learned is that the electronic components in the electrical vertical takeoff and landing system is going to play an incredible role. So if we speak about flight control system interface between flight control system, mission computer, avionic, and propulsion system, this is something which is based on platform which can be standard and already traditional and already qualified and certified, but which is going to play the new role. Our pilot was not in the aircraft. Our pilot was in the control hangar, and he was controlling the helicopter based on his feeling watching a camera. So the flight control system was the translation of his stomach inside the helicopter. And this, in order to be sure that what he was doing was correctly translated in maneuvers, we were taking a lot of time because we wanted to be very sure that every risk was mitigated. So I must say that once the hardware is there and it's installed, the electronic is going to play a major role.
Okay, great. Thank you. Olivier, I'm going to hand over to you now and looking forward.
Yeah, thank you, Erin. Thank you to the team for facilitating this, but also thank you to the passion that came from PK, from Gabriele. I like your wish that you stated at the end, very much in line with probably everyone who is here on this panel. Dana and Adam, thank you very much. Really appreciate it. I feel really honored to be part of this distinguished panel today, talking about supply chain in the UM ecosystem, or shall I say actually ecosystems. I have to admit, when I prepared for today's discussion, I had to ask myself what exactly is meant by supply chain in this context, and what context actually are we talking? When we're talking supply chain in the automotive industry, we heard impressive statements today. I guess we're very aware of the hundreds, maybe thousands of contributors in the necessary supply chain to provide a highly differentiated product to customers around the world. And the same counts for the aviation industry, with well-established contributors around the world, and both industries are essentially parts of the global race around UAM. But also, I have to say it in a very humble way, also software providers such as Lufthansa Systems and many others are part of the huge bet on something we named UAM without really knowing who will make the race and how exactly the result will look like. The only thing I know is that IT is also going to play a significant role here. And yeah, the broader context actually includes the whole ecosystem of travel and transportation and its necessary infrastructure, be it eVTOL, those electric vertical takeoff and landing hardware like Lilium and Hung or Volocopter, be it vertiports and its infrastructure around, be it low altitude air traffic management or travel platforms that feed those infrastructures, like RoadJet or plenty of other startups in this context. Some of you may heard about this, others maybe not yet. Now, when I talk about supply chain and our possible contribution, I'm not looking actually at the resilience we spoke about earlier of supply chain, such as maybe IPRs, which are always very close to us as an IT supplier, but also supply locations, country risk, or capital market access. For today, actually, my vision is a different one. We are all part of a revolution that can easily be compared with the times when modern jet engines in the aviation industry were invented, or maybe even when cars became accessible to the masses. Thus, we're part of a tech revolution which is serving the greater good. And that greater good is to build an ecosystem or many ecosystems which will allow humans to live in an eco-friendly, a convenient and actually highly populated world. It sounds like a convenience, but it's more a challenge actually that we're addressing here. And we can only create this together and not against each other. And also we need to understand that there is a lot of experience out there which will speed up time to market on one side, and on the other side will increase acceptance, which is still very, very necessary. And this joint approach actually, for us IT providers, this is not really new, but I feel that in the industry, still everyone is looking into their own ecosystem and is trying to get the competitive advantage out of it. I think in this industry and in this ecosystem, we can only win if we join forces, otherwise it's going to take too long. So the guiding question I brought with me today is the following. What are, for me, the most important challenges to the current UAM protagonist to overcome, and how can Lufthansa Systems humbly contribute here? The first challenge is the step going from manufacturer to operator. In recent years, much of the UAM market has been devoted to prototyping and initial test flights, but now what does it need to become an operator? As an operator, you have to establish several processes, systems, and data sources for all business functions, as we heard already earlier. And yes, as we heard from my previous speakers as well, necessary approvals of the provider's conformity to the requirements of the civil aviation safety agencies may not be underestimated. And again, here we're quite experienced, not only within the last couple of years, but it's part of the industry that I stand for. Certifications is a complex and long-lasting process. I'll just give you a very easy example. The certification of our in-flight info system, for example. So just putting a server into an airplane, it took us 9 months. And for those who are not in the industry, that seems to be long maybe, but it was the fastest process actually in the industry ever, and we're quite proud of it. As a global provider, we gain from experience with local authorities and specific requirements. And in the example I just mentioned, that was actually key. So you need to have the network, you need to bring the people together, and it only works on reliable networks that you have established actually over the last couple of years. So the message for the first challenge is get the knowledge and learn from a classic transport operator like an airline or a mobility operator. The second challenge, getting a prototype into serial production. It sounds easy, but it is not at all. In serial productions, reliability, and some of you actually mentioned that as well, is the most important thing. Reliability in any aspect. For example, with regards to quality, but also process timing, speed to market, scalability, operations concept 24/7, human resource development. We spoke about human resources not being sufficiently available, and I fully agree on that. In the IT environment, we're very much used to that, and we're sourcing around the world, and it's difficult to get the right people on board. And not forget, of course, different production sites come with different local specialties to consider. As I pointed out earlier, a global partner like Lufthansa Systems will provide global experience for global reliability. And the fact that IT companies like ours are very used to rapid prototyping, MVPs and agile setups in an environment where safety has a highest priority, that certainly helps. Companies who want to scale have to have a stable IT infrastructure and professionalism. That also counts for this industry. And on the other side, the hardware learnings to evolve from prototype to serial production can be taken from different mobility players like automotive and helicopters and airlines, as we learned earlier. And my dear colleague, Thomas Wittmann, who is with me on the board of this wonderful company, who spoke in one of the first sessions, pointed out the specific capabilities software providers possess in this industry, be it data for classic flight planning, terrain data in a dynamic environment, but also crew management, revenue management, and so on. All of this makes sense in a highly integrated and stable environment, which is proven and accepted by authorities, and all those who are actually also flying around in this crowded and even more crowded airspace in the future. Last but not least, another great challenge will be the switch from manned to unmanned operations. To be ready for the future step from manned to unmanned, and to enable autonomy within the regulatory environment that is still developing, fully automation is required. And I know this is still a buzzword that many people fear, just looking into the airline industry, where customers are still not really believing that an object flying without a pilot on board is a safe thing. We need to work on that. So for unmanned operations, IT systems need computing power and speed to reorganize the air traffic in real time, as airspace is going to increase even more due to UAM. The future of UAM IT has to provide, therefore, optimal situational awareness and get all necessary information in real time to operate the aircraft safely. It's about data and also how to handle this data. The optimization won't happen on individual UAM, in my eyes. I strongly believe that the future lays in the total network optimization, which is actually a vision we're pursuing already in the airline industry. And in particular, automation of commercial aircraft is actually our business. For example, the flight planning into our Lido product, so it's flight planning in general, for instance, almost completely automated already within Europe. And looking at data and IT ecosystem, I'd like to start with the challenge of data availability. New sensors in the city, in the aircraft, are required to generate the data needed for a safe operations. But let's be honest, they do not exist today in a sufficient capacity. Another field where suppliers will evolve and will be part of the supply chain. Another interesting field, we need to find solutions around data handling and ownership. As I pointed out earlier, the provocative question is whether data will belong to its owner, or will a certain amount of data have to be legally shared with all use-based participants like cities, UAM operators, weather providers, and so on. And last but not least, data security, of course, is also a huge challenge in this context. So I share probably the same passion that all of you have around this topic, and therefore, looking at the time, let me conclude with this. The speed to market is certainly crucial. The best way to accelerate and to reduce failure is to innovate by building on existing solutions, processes, and data. And I'm not talking to not accept there's new technologies out there. I'm just saying let's not make the mistake and don't refer, at least, to the knowledge that we have gained over the last years. I'm very much aware that UAM is not the same industry as the airline and airline IT industry, but I'm very sure that, and let me put a bold figure there, 70 to 80% is actually very close to it, and it wouldn't make any sense not to make use of it. So if I had a wish, Gabriele, I can't top the one that you put on your slide, but the industry, in my eyes, needs to continue to join forces and to build on existing technologies, approaches, and safety concepts. We're ready to contribute. We'd like to think a bit in the MVP context that was mentioned, but also open source, because we believe that for the greater good, it makes sense that we all join forces here. So thank you very much for having everyone here today. Very much looking forward to a great discussion.
Thank you, Olivier. Very good. Just coming off of what you just said, you said 70 to 80% of the IT that we have within aviation, it could be transferable to UAM. Different industry, but a lot of learnings that could be transferred. What do you think the main kind of knowledge transfers that you could see coming from classic aviation systems into urban air mobility contexts?
Well, the airline industry offers lots of parallels, but also lots of differences as well. I don't want to hide that. Currently, all let's look into maintenance, for instance. Currently, all minor maintenance events are done in hubs, but there are mechanics at every landing site. I think the operators and their partners will end up developing rules and systems for ops processes, but in UAM, it will take a long time to build up scale. So the costs per takeoff and landing, per maintenance check, per battery change will be exorbitant. And as you might have underutilized staff in every location. So what we're used to in the airline industry as well is to handle actually data, as I referred to before, from and for objects flying around. We develop plenty of algorithms to optimize trajectories, performances, and safety. And as I said, it would be unreasonable not to cooperate with these players in this market.
Okay, thank you so much. Leads us to now, this is our last speaker for the short presentations, leads us now to the panel discussion. We've been collecting questions from the audience, and I would like to send out a question that I find also very relevant, and it is as follows. What do you consider a successful adoption of UAM in a first phase? I'm referring to a number of people using such systems. I'm sure this would be in phases, but assuming a few thousand air vehicles with just a maximum of 4 people per flight, this is a very limited number of passengers in order to build up this entire ecosystem. I think this question focuses on financing this whole thing and maybe break-even times. I'm going to give this question to Adam. I think you're the best position maybe to answer this one.
Sure. Yeah. Thanks, Erin. That's a great question, right? It's one of the reasons actually we're taking kind of such a holistic approach to it, to be able to pull all those threads together. It's not just building an aircraft or building a vertiport or getting supply chain right. It's how do you bring all of those aspects together, kind of what I was talking about before. And I think a successful launch, it may be different for different folks, right? But a successful launch, in my opinion, is being able to bring all of those different aspects together. That first and foremost, it works, right? And it's a combination of being able to produce the aircraft, certify the infrastructure, the airspace management of it, aspect of it is something we haven't even talked about yet today. And it's bringing all of those market factors together, leveraging existing things that are in place, building upon them, and then preparing that for scaled availability, right? It's going to be capital intensive, especially from an infrastructure perspective. People always say to me, hey, what keeps you up at night about this whole thing? Be quite honest, there's obviously challenges in supply chain and certification, everything you had to get over, but it's really the rest of the ecosystem, in my opinion, working by, with, and through local elements to get land utilization for where you're going to be able to fly, airspace management aspects at the federated levels, and being able to pull all those things together and then prove it out. right? There's a burden on the industry to go prove it out. It's not really on anybody else to just say, hey, yeah, you guys can all come in and go do this across industries. It's the burden is on us to go prove this before we can take it into scale, right? Because it's going to be difficult for folks to and cities and states and provinces, et cetera, around the world to be able to just accept it. I think that was one of the words somebody used before. How do we just have this accepted, the public acceptance aspect, before we can really drive more investment in it and more scale from everything off the vehicle as well? So that's why we're taking that holistic approach, and that's why we think it's going to take time, right? That's why we think the timeline is extends out in the late 2020s to the 2030s to be able to really ramp up from a scale perspective, not only from that the investment aspect, but you got to get people to use this as a service, right? So there's a lot of threads that need to come together off the aircraft, the aftermarket services, the infrastructure, being able to kind of get that all certified, all of that working together, drive standardization, and interoperability in the marketplace, so that it's not just Hyundai doing that, or it's not just fill in the blank other OEM doing that, or infrastructure provider. How do we bring those together too? Right, that's where you really be able to start driving scale in the marketplace. So multiple different aspects, but it's gonna take time. Hopefully that at least starts to answer the question. But it will start smaller, kind of like PK said, and then you'll hit this inflection point when the right levels of public and private investment come in, really everything off the vehicle to go accelerate that growth.
Do you see that in the same way, Dana, from your perspective, and have the Department of Transport made any kind of predictions of when this thing will start to scale and boom?
So the human capital aspect of this is what keeps me up at night, that and access to neodymium. And there have been various predictions about how many pilots the current commercial aviation market's going to need. CAE did a study earlier this year that said about 250,000 pilots by 2030, just to replace retiring current commercial pilots. Not to mention the plus up we would need for advanced air mobility, which McKinsey estimates at about 60,000 by 2028. Now, those are things that cause us to wring our hands quite a bit, but I agree with Adam. The initial issue probably isn't going to be, because the scale is going to be small, pilots. It's going to be, you say, what's the definition of a successful rollout? My definition of a successful rollout is one where these vehicles start to interact with the public in a way that increases public acceptance. Whatever that happens to be. I think a lot of people argue that it'll be medical, right? Medical response, maybe not ambulance services, but bringing providers to the scenes of accidents quickly when ambulances might get stuck in traffic. That's a relatively small scale use case compared to the the sort of the Uber vision of a few years ago, but it's going to increase public interaction and acceptance with these things. And if it's at a relatively small scale, fine. Right, we're starting to get data back on how the public feels about this, how the operations work. I think, Olivier, you brought up some very good points. Managing traffic flow, managing pilot assignments, managing the flow of maintenance personnel, all of this gets to one fundamental aspect of the economics of this, which is utilization. These aircraft only make money if they're in the air as much as possible. Now, that's not to say anyone's going to sacrifice safety, but right behind safety is the utilization question. And so those sorts of software, IT-based solutions that are currently in the market for commercial aviation, I agree with you, those could transition into helping optimize utilization among advanced air mobility vehicles quite easily. And I think that's a really, that's going to be a big win if we can pull off that transition, because that really gets to the economics of all this, because public acceptance obviously is huge, but economics plays a role as well.
Yeah, I'm glad you mentioned that, because this is our core business, is optimizing every single aspect of aviation to try and squeeze the last drop out. Olivier, I think this is a good segue for you if you would give your perspective, because these are essentially all of the things that exist in our products.
Yeah, I just wanted to actually pick up, Dana, what you just said. The human capital seems to be much more the bottleneck here, because and please tell me, you're much more an expert in the financing of these huge these things in these industries. If I look into the airline, the classic airline industry, you're absolutely right. It's the same there. If aircraft are not in the air, they don't make money, and we can see it now in the crisis. It's a catastrophe for the entire industry, right? And it will be the same for UAMs. I'm pretty sure about that. But we have one big difference in my eyes. I would like to see whether you share that view. We do have a lot of capital out there if it comes to money. Everyone wants to invest, though not everyone is willing to put all the eggs into a certain basket now, because we don't know how it's going to look like at the end of the day. So my feeling is the bottleneck is actually not the financial capabilities of society overall. It's much more the question, where is this really heading? And does it then make sense to capitalize it by having then aircrafts in the air who really make money? Would you share that view, or do you see it differently?
Well, I certainly think that there are different margins built into these different use cases, right? And I think probably the thinnest ones would be the sort of mass air taxi market, where those margins can be very thin. I've read some calculations, and again, you know, I'm under various NDAs, so I can't talk about it in detail, but those calculations are being made by most of the OEMs or potential operators, and they're very, very thin margins in the air taxi space. Other areas, it's a little more inelastic, right? I think the medical response being a good one. I mean, the typical helicopter medevac run costs in the United States $86,000. That's for one trip, right? Now, again, there's inelastic demand for someone who's got a shotgun wound, right? So that's a case where you may be able to, you know, to have margins where you don't need the vehicle in the air all the time. This is one of the issues that makes medical response so expensive, right? Is because those aircraft are parked the vast majority of the time, right? They respond to a couple of calls a day. They're in the air for 2 hours a day. That's why it's so expensive, because you're paying fixed costs for pilots to be there, for the vehicle to be available and in a state of readiness. And so, you know, there's a very high fixed cost associated with that, you know, and advanced air mobility can't really do too much about those fixed costs. I mean, the maintenance will be much easier, but you still have to have pilots and dispatchers and a flight nurse and all these other people available, just like you do with a helicopter. So there's overhead there, but there's also the potential to have lower utilization and still have a functioning enterprise. One thing I would like to flag is also this idea of what assumptions are we making around pilot fatigue? We talk a lot about pilot qualification, and it's rightfully so, right? There are a lot of moving parts there, because simplified vehicle operations may allow us to change, you know, in cooperation with the FAA, some of the certification requirements, how much time you can spend in a simulator prior, you know, how valuable is a simulator, and some of these very high fidelity simulators could be game changers in terms of having to qualify masses of pilots. But the other thing I would say is, if you look at, say, a 15-minute flight in an air taxi, a very high proportion of that flight involves flight critical operations. When I say that, I mean taking off, transitioning back, and landing. In a 15-minute flight, you may spend a third or more of that time in these very labor-intensive, stressful, fatigue-inducing environments, relative to a traditional commercial pilot who spends a fraction of their time involved in those things. You know, a long-haul pilot may spend less than 1% of their time dealing with those things. So what does that do to pilot fatigue? And, you know, when we see these numbers about how many pilots we're going to need, or if, you know, as Lufthansa, you're building in an algorithm that schedules who, you know, how many pilots need to be where and when, you know, we may be dealing with much more intense operating environments and much more need for crew relief and you know, crews to swap out several times a day, because it's going to be very taxing on these guys to spend, you know, a third of their time doing the flight critical things, you know, 12 or 14 or 18 cycles a day. Yeah,
I fully agree with you, and I think it's a challenge. But again, I think you pointed it out beautifully. It's much more about the circumstances and not much about technology. For instance, technology is there. We can even the unmanned. I mean, I have to be careful in this industry to make the bold statements here. But from a pure IT tech perspective, pilots' fatigue can be addressed by the simple fact that we don't put them into the vehicles anymore. We have them in a very different environment where we can address totally different needs, and that is something. It is not that far away in my minds. It's a change process in our minds. We need to prove again and again, and what's happening right now is actually actually adding to it, right? There is a lot of vehicles out there with of course not humans being transported, but that are proving also to the broader public that this is working. And I think we need to get to go that path more and more, and then we will be able to address exactly the topics that you just mentioned, which are of utmost importance, of course. And I'm not talking about an industry that is coming from one day to the other. Of course, we will still have the Airbuses and Boeings flying out there, and I mean, we're purchasing now the aircraft that we're flying in 15 to 20 years. Like every airline is doing it like this, and it is still going to be there. The question is, how are we going to combine this, and how can we get the best of the two worlds at the beginning? And I am very convinced, but this is my very personal statement here, that not too far from now, we will all experience this. We will have unmanned, also huge aircraft flying through the space.
There is one point, Olivier, I'd like to complete, let's say, my point of view here. There is one point you mentioned, which is very important. So we have a lot of challenges now. We were speaking about the number of pilots, the number of aerospace engineers, the new engineer entering in the new world, electrical engineer having responsibility in the aerospace development, and the stress and the fatigue of the pilots we are having. And you speaking about acceptance. So Adam was mentioning in the beginning. I've been in the last 2 years on the field looking at this vehicle flying. A few minutes, of course, we need to make step by step. And in the beginning, we were not trusting to make any single maneuver. At the end of the flight test campaign, we are doing something which is comparable to the helicopter. And I think the acceptance of the audience, the acceptance of the population, it's an incredible point. I come from the helicopter industry. And if I speak with my friends and I say I'm working in the flight taxi, most of them are looking at me like crazy, because we work in the urban air mobility. If we stay a little bit longer in LinkedIn for a couple of hours during the day, we believe that urban air mobility is already flying. Yeah. and the population does not see it yet. They don't see the helicopter yet. The helicopter coming, when a helicopter comes, the kids are looking at the sky as a marvel. So I think to come back to the original question, the crack will be when we allow the operation. So an operation, from my point of view, the first operation will be to fly in order to complete the transportation offer. So I don't think we are going to replace the cars, to replace the trains, to replace the normal aircraft, but to complete the infrastructure. If we complete the infrastructure offer, and if we give an opportunity to do something better, safer, faster, for something that is normally very difficult, then the people will see that there is an opportunity, that there is an advantage, and it exists. And the acceptance of the existence will bring us to make step by step. So I don't believe we will need 20,000 pilots on the first day, the first of this vehicle is certified. And I don't believe as well, Olivier, to come back to you, that we are going to fly autonomous from the first day, but very soon, like you told. And one of the cracking point is not convincing EASA that this is possible, but it's convincing the people that this is the product of the future.
Very much right.
Yeah, Gabriele would just add, and I completely agree. That's why the focus on public acceptance, right, is not necessarily the technology. The technology bleeds into it, but people have to be willing to step on an aircraft, either piloted or not. And it's to your point, Olivier, it will be autonomous in the future. It won't start that way, but it'll go that way. And that also feeds into, Dana, your point on direct operating costs. It's a major factor of it down the road. But there's a very small percent of people that have ever stepped on an aircraft across the world at the grander scheme of things. And then in a smaller aircraft, and then potentially a rotary wing or vertical takeoff and landing type of aircraft. And proving that to them and showing them that A, it adds value for them, and B, well, probably first is safe, and then B, adds value. To your point, Gabriele, it's huge, right? We're taking a huge focus on that. And that's one of the areas of looking at it from the customer journey and that whole experience, and how does it integrate with everything else? So it's not just the standalone service; it's got to be integrated to everything else, and technology has to integrate it too. Olivier, to your point, right? But we have to be able to prove that to people. We have to be able to prove that to not only the public, but that drives investment because that'll drive scale in the end of the day. And eventually that technology will help lower the operating cost as well, which is going to be important. To your point, Dana, you're spot on. Max utilization at the lowest cost, right? Without violating anything on safety ever, and providing an exceptional, seamless service to the end user. That's one of the challenges we have.
I have a question, which I like quite a bit, and I also have been wondering this for myself. I'm going to send it to Dana and I think Gabriele. Some players today are having quite deep vertical integration, combining, for instance, OEM, operator, vertiport, manufacturer, operator, IT, etc. Do you expect this trend to remain or to consolidate, or will the players increasingly concentrate on single parts of the value chain, and when? Dana.
My standard answer to that question is that we are agnostic as long as it can scale. And that's the real question about the very heavily vertically integrated firms, is how will they deal with big orders, and how will they step into operating as a Part 135 operator in the United States, for example, when, okay, people say these guys have never built an aircraft before and now they're going to. Well, they've also never operated an aircraft before and now they're going to. And so, how willing are they going to be as having a culture of vertical integration to working with partners who've got experience in the operational aspect of this? Because there are risks involved with rolling eVTOL out, or AAM out. One, of course, is that there's an incident of some kind. One is also that the public won't accept it. But I think a very real risk that's lurking underneath all of this is that the rollout just flops, right? That it gets mishandled, that they can't fly on time. They don't have the right maintainers in place. They just don't understand the logistics of the flow of people and traffic. And this is something, Adam, you were getting at, this seamlessness of how this is going to work, because people are not going to sit around for 45 minutes to wait for a flight that's 10 minutes long that saves them a half an hour. So, getting that right, or, on the converse, getting that wrong, I think is a big risk here, that, it's maybe less obvious than there being some kind of safety incident, but it's a big deal in our mind. And it's something that we think about all the time. So when we talk about, vertical versus a culture of relying on partners, we see that runs the whole gamut in terms of philosophies, but I really am, somewhat concerned that just from a cultural standpoint, at some point, these vertically integrated guys are going to, number one, have trouble scaling the vehicle hardware itself, but number two, be resistant to working with partners when it comes to doing the actual operational work. And the one thing that may help is that I think, to save time, a lot of them will end up incorporating themselves into current 135 operators who have a little bit of experience with that sort of thing. But I think it's a cultural issue, and it's certainly something that we think about quite a bit.
Olivier, you mentioned earlier about the importance of the stability of the IT. So we are an IT company serving the airline industry, and this is an industry which is very saturated and very mature. But when there is an IT disruption, what is the fallout? What is the financial, operational? I don't know if you have any figures. I'm sure that it's happened here and there. Maybe not with our products, but I know that it's happened. The website falls out, the booking channels fall out. What actually, setting down a very big number here, what is the actual fallout?
Well, you can see my face. I actually don't like to talk too much about systems that are not working and falling out. That is in particular regarding the topic that we just touched earlier. It's exactly what creates the fear of the people, right? What happens if the system doesn't work? And we're not talking too much. Interestingly, people have a lot more trust into the engines, into the hardware, and not too much trust into the software. And for a simple reason, they sit in front of a screen like I do, and maybe it's an old machine. As you can see from my camera, it's a 12-year-old Mac. Interesting for an head of an IT company. But this is where the psychological momentum kicks in, which we need to really address and work on. I mean, all speakers have focused on that. This is a change process, and that leads me a bit to the answer of your question. I mean, technically, we're far ahead already. When I only look into IT capabilities, we would be able to fly objects without any pilots on board from an IT perspective, without, and now I have to be careful with what I say publicly, but without any risk. Again, it's from an IT perspective, and it's a bit saying this without really having to do it at a point in time, right? But even if it's not possible yet, it is going to come. And if we look into what IT has been providing to the airline industry, where I believe there's a lot of similarities, we spoke about terrain data, we spoke about flight plans, which are actually optimizing taking terrain data or any kind of objects into account, even moving objects into account. We're already uncomparably far if you look into what we were able to do 10 years ago or even 5 years ago. So I think we need to be very open to understand that technology from an IT perspective is not a bottleneck at all. It's more the psychological momentum, and we need to prove it again and again. And the cost factor that you were referring to, with IT, that's always the big challenge. All board members of whatever companies, they always say, okay, IT, when it works, nobody talks about it, right? When it doesn't work, everyone talks about it, and everyone has an opinion on it. Again, I like a world where technology is key and knowledge. This is not what I see when we talk about IT and the perception. And yes, it may have as an effect huge cost impacts, because if solutions go down, then you might have no bookings anymore or whatever. And this is the impact that is huge. But it's not a challenge or a lack in the IT itself and the algorithms that we're providing. It's only the consequences of the business that we're serving. And we need to talk about redundancies and possibilities to catch this somehow. But I don't see this too much as a challenge, to be very frank.
Okay, great. Hi, PK. I have a great question from the audience again. And I'm going to send it to you because I think this is right up your alley, quite frankly. So how does an eVTOL OEM manufacturer, how can they put complete requirements forth towards suppliers and enter into development contracts with suppliers when there is a complete lack of airworthiness requirements and regulation being finally written?
Great question. So I'll just first let me take an opportunity to answer the previous topic, because that is also near and dear to me. And the IT system for digital twin or digital ecosystem of supply chain is absolutely critical for two reasons. One is efficiency from end to end. The OEMs need to be able to say my production needs to be increased or change it based on any low tier supplier says, oh, look, I have a challenge here. Right now, that dynamic coordination does not occur, and that is essential for planning and real-time adjustments for resiliency. The thought that part of the supply chain is always prepare for things that could be disrupted. So disruption of IT should be part of the risk management of supply chain network. So what would happen if I don't have one or two places where internet goes down? How would I manage that? That should be part of the whole supply chain risk management. That's the point I was going to say. So essentially, the digital supply chain network should increase the efficiency for lower tier suppliers to get information, aggregate demand from multiple OEMs, and OEMs to get information about lower tier suppliers and their capacities and their current status on a dashboard, real time. So Oliver should be able to sit, or Adam, he should be able to sit in his desk at 6 o'clock in the morning, checks out the dashboard, says, here are the things that I see going on. Everything is hunky-dory. I go to the beach, come back after a good jog. But if there is some problem, then they should be able to immediately say, okay, well, what do I need to do to switch from one supplier to another to maintain that rhythm? Because at the end of the day, you are committed to the deliveries to the customer. So that's another thing to think about it. So disruption management is actually part of this supply chain and digital network. So I'll leave that alone now. Go to the question that was asked. So sorry for a long-winded detour here for a scenic route. But the question is, how can they basically engage with the suppliers when they don't have a production certificate? It's a good one. What I would say that is we go back to those 3 S curves that we talked about. Pre-certification is one S-curve. The pre-certification S-curve, you are really trying to do prototypes. You need rapid access. I think that's when you start to cultivate the interest of the suppliers. That's when you try to understand the design traits and manufacturability. So a designer designs one type of shape and form and all that. That doesn't mean that is the ideal way to actually manufacture that. So getting engaged with small and medium-sized enterprises earlier on for these prototypes would be the way to understand how actually you can change. The value, the true value for OEMs is those iterations that they need to do and optimize it based on manufacturability as well as cost and other things, not just based on how the design looks like or what the design criteria looks like. I think there's a give and take that happens. Gone are the days where Cupertino in Apple designs stuff and throws away to some other country and then they just pump out manufacturing. Now it's all about basically how they do iterations together and optimize on multiple fronts. That is one of the key advantages of involving suppliers right from the beginning. The manufacturability, those suppliers have been doing that for over and over again. They have a very good insight into what it takes to manufacture at high volume. So if you engage with them right from the beginning, I think you're likely to get some advantage of their know-how rather than building everything from inside. So that's one of the reasons why I would encourage you to start working with the suppliers for the, granted, in the beginning, it's the small and medium-sized suppliers you would be working with, but as you start to scale these operations, you will get more and more insights. So the manufacturing and design for manufacturing is a really critical issue that we need to start to look into right from the beginning. That's the reason why we should engage with them, even though there is no certification yet.
Okay, PK and Erin, I'd like to contribute here. I feel very encouraged about your words, because this requirement definition is our daily nightmare. So I wonder if one of my guys wrote this question in the chat, because the question is always, please feed me with requirements. Did your customer give you the requirements? Why don't you give me requirements? I don't know what to do if you don't have requirements. So what you were speaking is valid on several levels. Now you were speaking about early engagement in supply chain for manufacturing, but also for design. So what we are sort of our philosophy is that we want to be engaged with the aircraft manufacturer from the concept design, so that we can feed with information already during the issue of the concept design. There are a lot of new players which have wonderful concepts that we look aerospace older people and we think I don't understand where to look from. So let's make a step together. It will not become uglier, but it will become more real. And that's part of the, I think, also answer to the integration, vertical integration question. So you're speaking with somebody who told competence is one of the key milestones. So I like to think about what I'm good of and to develop the best propulsion system together with the OEM, with the aircraft manufacturer, and together with my supply chain. From the other side, I appreciate very much these companies, without mentioning the whole of them, which are thinking vertically, which believe that there is no solution which is an integrated solution. The solution is there, it's not integrated. They are suggesting and also pushing ourselves, established company, to enter into this integrated solution, integrated mentality, and use what we have in terms of knowledge to make the step in the integration. So I don't think everyone is going to be successful, and that we have 10 services which are all successfully deployed and all working all together. I believe that at the end there will be an integration of the existing supply chain into the integrated world.
If I could, I'll chime in there just based on some experience I've had talking to suppliers, right? And the first instinct that when you're looking and trying to evaluate a supplier to see what they can do is to try to find their catalog, right? To say, okay, what is it that we can buy from you off the shelf? And most of these firms, especially the smaller ones, don't have a catalog. What the conversation is more like, well, what do you need, right? We can make whatever you need. You want a 1/4 megawatt? Sure. Or if you want 20 kilowatts, we can do that too. But we need to know what you want and what levels of efficiency and what voltages and all these other various things, these parameters. So you can't really just go and browse their catalog and assess their capabilities. You need to really have kind of a more person-to-person discussion. And I'll tell you, I was talking to the developer of a lift plus cruise design, right? And there's this design trade-off between efficiency and weight, right? Basically, if you want a motor that's very, very light, it'll be slightly less efficient. It'll burn hot, but maybe it doesn't need to burn for very long because it's your lift motor, so it can be relatively inefficient, build up heat fast, but only run for 2 minutes and you're fine. And then your cruise motor is relatively heavy, but also, relatively efficient and relatively cool. And so you're balancing all the, how long is it going to burn? How hot's it going to get? How much can it tolerate that? What's its continuous versus peak performance characteristic? And so when you start talking in those terms with these guys, they get a lot more comfortable, right? Because they're like, okay, now you're talking in specifics that I can estimate parameters for, how long are these going to last? How long can you keep them on? Do they need to be air cooled? Do you have to turn wingborne within 5 minutes or they burn up? There are these various trade-offs that you can discuss. But the idea of these guys, especially the small ones, having an existing store full of things that you can just go buy, I mean, that's not really how this works. It's much more of a custom one-on-one conversation. And to PK's point, that's more like almost an agile development kind of approach, right? That it's this iterative back and forth. You help me define my requirements just as much as I bring them to you, because I'm going to be modifying my design to suit what the art of the possible is in terms of components I can source.
Yeah, I'd like to add as well, because I find it really interesting what you started with. If we look into certification, we spoke about this earlier already today. There is a lot of experts in the industry with knowledge and also connection who are able to go through certification processes. In the airline industry, it has a lot to do with the network that you're in. But we need to make sure, and I think Dana, you just said it, it's an agile setup somehow, right? We need to make sure that we balance the interest of having something which is already certified and well established, but you also want the innovation and you want the new things to come on board. And there you have to see, okay, does it take longer to certify something that is going to be developed for whatever specific part of the industry, or do you want to rely on the things that you're having and then somehow narrow your mind because you're not getting into the innovative approach that you're looking for? So I think it's a balance. It's something that you can't give a statement which fits all. You need to look into the specific fields to make sure that you get the best out of it that we need for this development.
And we've even found that some of the operators are looking to us to help them with certification or to help them with setting up the standard with regards to some of the topics where we're a bit stronger. And I was wondering if, I know, Gabriele, you have quite a bit of contact with these guys as well, if they're using Rolls-Royce and using the competence there to shape the regulation and how, where else are they going in the supply chain to help them with that?
Yes, of course. Yes, of course. I think we need a clarification here. So we don't expect EASA or FAA to write requirements for us and we stay static and we don't pull them. On the opposite, EASA and FAA don't expect we to develop the system and then to present it for certification. This is already happening. I think we need to clarify to the audience here. We do have a certification base, and this is a luxus compared to 3 or 4 years ago. We have, in Europe at least, a special condition eVTOL 01. We have a special condition E19. We have applicable means of compliance. The same is happening in the US. The FAA is following Magni X. The FAA is establishing special condition, the parallel of the special condition. They are following a concept. So they are not following just throwing it in the United States or throwing in the European world, but there is, of course, customers or, let's say, industries which want to certify systems. So what happened in the last, I think, 3 to 7 years is that we enter into workshop discussion with all regulation authorities and standard authorities, so establishment of standards, in order to write the regulation of the future. And this is happening here. If you look inside the applicable means of compliance for the E19, for example, which is the certification basis for the certification of the propulsion system, electrical or hybrid, you find the comments from us, not from Rolls-Royce only, but from the industry. Everybody has already contributed there. So this is not the end. This is only the first version. We are on the second version for the applicable means of compliance, but the dialogue is there. There was an early involvement of the industry or potential industry of the UAM of the future with the regulators, as well as we have to do as industry with our lower level, I would say, compared to Lufthansa or our iframers supply chain. So we cannot believe we have the design ready and then we look for suppliers. We have a total early involvement of the suppliers, which are mostly for power electronics, for example, coming from automotive. And we need both of us to change our mind, to change our approach, to understand the new language. We speak totally different languages. And this is one of the key. It happened already for the regulations.
If I could chime in there for just a moment regarding, there's a relationship between certification and standardization, right? And we had this question earlier about, if I had one wish, if I had one wish, it would be that we could get the leading vehicle OEMs all to sit around a big table, a big round table like the United Nations, and all agree on a set of maybe half a dozen materials that they're going to use in common, and a bunch of the sort of commodity components that aren't really differentiating IP that they can all agree that we're going to use in terms of connectors and relays and those sorts of things. And that would greatly smooth the process of certification, because you're dealing with a smaller subset of materials that need to go through. Because I strongly suspect, and I said this to the American Composites Manufacturers Association a couple of weeks ago and took a little flack for it, but I think that the OEMs all think that they're working in very different proprietary aerostructure materials, when in reality their formulas are all pretty similar to one another, and they won't discuss what exactly they're doing with each other. So we're not really sure that that's the case, but we've seen it in other cases. And so, if we could get them all comfortable enough that they could say, hey, look, we're going to talk about this in the light of day a little bit more, because it's going to help us all to get our materials certified faster. By narrowing them down, because they're all pretty similar. I think that would be great. And it is wishful thinking to think that may happen, but it would be great, and it would help all the OEMs to come to that sort of consensus about the things that aren't differentiating intellectual property.
I don't know to what extent it's happened in the airline industry, but I couldn't agree with you more, Dan. As somebody who's supplied to the airline industry for like 10 years, this is a really big pain point for all of the current vendors, and I'm sure for all of the future vendors as well. But I'd like to maybe, we have only 10 minutes left, or 8 minutes. I'd like to throw this question over to Adam. Which are the areas for you as a manufacturer operator that are absolute no-go, that you would not share any kind of IP or whatever, and which are the areas where you can see that nuts and bolts and screws are maybe in order of making a more efficient supply chain, also with regards to managing these vehicles in the MRO, which ones would you be more willing to get an industry standard that you and your toughest competitors are all in the same products?
Yeah, it's a really good question, and to piggyback off of what Dana was saying, I think on certain areas it gets challenging on the aircraft, right? Because even nuanced differences potentially in IP in the race to make these more maximize utilization and lower the direct operating cost becomes really, really important. So that's where that challenge sits, right? And then it's just kind of the nature of the beast sometimes, is people not wanting to share. But I do agree, and we say it all the time, is a push for standardization and operability. I think one of the places we're really making a big push for this, and maybe this doesn't really answer the question, is off the vehicle specifically, right? Whether it's airspace management aspect, the digital networking tools that need to happen there, which may be really near and dear to your heart over at Lufthansa Systems. How does that come together so that the aircraft, if we put the aircraft itself aside and some of the IP on the aircraft and the airframe or the motors or something like that for a second, The air is off the aircraft, so these can all interoperate together, use the same digital and physical infrastructure. I think those are key. Those are key aspects, right? It gets a little bit more complicated on the vehicle for some specific components of it. But if we don't have those aspects of standardization, interoperability off the vehicle, how they move through time and space, how they communicate with a ground control station, or how they communicate with each other, you run into a very big challenge of having this whole model kind of come together and work, right? So I see them as kind of separate pieces. Now, some of those are components obviously go on the aircraft where you need to look at standardization. But I'd be hesitant to say for some disclosure purposes of where you would want to look specifically on the aircraft where some of the the IP could be shared or something like that. But absolutely in areas within the ecosystem, I think it's imperative. If we don't do it, it makes it very tough for the industry to move forward at scale, to be quite honest.
Yeah, this was also touching on what Olivier said before about the data and who owns it and what has to be shared. This is, I think, another issue that we could spend a whole other 2 hours talking about. But looking at the time, we have 5 minutes left. I'd like to go around and give you each 1 minute to give your last thoughts. I'm going to turn to you again, Adam, because you're top left. So go ahead, last thoughts, 1 minute.
Yeah, last thoughts are just, first, again, thanks so much for having me on, and thanks for setting this up on supply chain. I think, Olivier, you had mentioned that when the IT systems are working, nobody pays attention. When they're not, you're the target of everybody. I think it's kind of similar for a supply chain perspective. When it's working, nobody pays attention because it's maybe not always the coolest aspect. In this industry and what we're trying to do, not just at Hyundai, but the whole industry, this is absolutely imperative to be able to get this right. And we got to shock the system to a certain extent. We got to do it through regulation. We got to do it through certification. And we've got to do it through really innovative agreements, honestly, between OEMs, partners, and kind of everybody in between, right? So it's a bit of a brave new world for aviation and where we can take it. More discussions like this and more pulling together, the different parties in that is going to be really important. And again, thanks so much. And this is exciting. Really looking forward to moving all of this forward with you guys.
Thanks, Adam. PK, last words.
Yeah, sure. Thank you. So the old joke is nobody cares about suppliers till they miss deliveries. So that's kind of how it is. The importance of suppliers is really critical. If everything is going well, that's fine. But I think it's that needs to be set up right from the beginning. That is the main point. The supply chain is not something that happens overnight. It needs to be proactively built and set up, and there needs to be as much standardization as practically possible, and then IP where it's necessary. The standardization will reduce costs for everybody, for manufacturing, maintenance, repair, overhaul, turnaround times, all of that. So I think this is a topic that is very near and dear to me. It's important to set it up right from the beginning. We have several examples in the past of how the lack of proper supply chain has hurt our industry and increased the cost and delays and all of that. And I think we need to learn from it and really be proactive in setting it up. And I'm very encouraged to hear that you all are taking it seriously right from the beginning. So thank you for setting it up.
Thank you. Gabriele.
Thank you, Erin. First of all, it's a great opportunity to be here. I think it was a very good 2 hours for us all together. I'm going to use the word of PK and Dana to the idea of the dream of Dana to sit together and to issue standardization. I agree with him, and I will make a little joke about it and then you have to deal with the business case. I don't know if it works, this dream, but we have to point the dreams. And I think this is the very good way. And if I can say something what I learned from my experience as a supplier, we are always a supplier at every level, no? And I always I have understood, and I have a philosophy in my team, that deliver on time is incredible. So let's sit together, but let's listen to which are your ideas or our ideas in order to solve the problems. Which one are the problems? I know them already. I need to find solution in order to deliver on time. If we have this approach, then we can really realistically think that in 2025, like everybody is telling, we are going to fly and to demonstrate the first capability. Let's do it.
Olivier.
Oh, you're really going around the clock. Thank you for that. Well, BK, I'd like to do one thing. You offered at the beginning to get together at the beach. Actually, I would like to to refer to that. But no, on the honest side, on the serious side, this has been really a great discussion. And Erin, you and I, we discussed a little bit. If you put supply chain somewhere into an advertisement, nobody's really interested. And I'm totally passionate about it because again, you, but also Adam, actually everyone said it. If that doesn't work, and if the setup is not right at the beginning, it's going to be a huge trouble in the future, and it's going to cost us a lot. Also, not only in terms of money, but also in terms of trust. And therefore, I have to say, I really appreciate a lot that this round here has been a highly involved and passionate round around this topic. I hope we can make use of this and continue that discussion because it's important for the entire industry. And so let's carry this out and have the next conversation, whether it's somewhere at the beach or in sometimes even beautiful Munich in regards to the weather. So you're absolutely invited to come to see us as well. So Erin, also to you and the team, thank you very much. Very appreciated. Great.
Thank you. And Dana.
Well, so all my academic training is as an anthropologist and a geographer. And so when I think about these vehicles, I think that, you can't separate them from the landscapes and the people that they fly over. And the landscape isn't just the ecology, it's also the politics, it's the political landscape, it's the cultural landscape. And you can see that reflected in the approaches that different municipalities and countries have to regulating and working with these vehicles, right? And so I would say that, when we think about supply chain risks, obviously there's the human capital piece, which is the engineers, the pilots, the MRO technicians, the flight operations people, that there's a supply chain there. We need a supply of talent. But if you think about community acceptance, you could also say we need a supply of passengers, right? And so they're part of the supply chain too. And so that's heavily conditioned by public acceptance and the landscapes culturally and politically over which these things fly. So I guess what I would say from a supply chain risk management perspective is it behooves us to all understand the regions and the localities over which these are going to operate so we can appreciate the nuances affecting that supply of passengers and human capital.
Absolutely, and I'm glad that you finished on that topic because the experience of the passengers and the acceptance is something which I think is for everybody, along with safety, even a greater issue than the supply chain. In fact, of getting the actual people to want to be a part of this and to want to grow with this and use it as a part of their everyday life. We have a few events coming up in the next few months to round out this series. Maybe we'll keep going. It's been pretty successful, I think. It shows us that there's a lot of interest in talking about this, and the industry is moving really quickly. We will have a customer experience and acceptance event in September after the flight operations event in July, and then we will discuss. We put this event a little bit later because I think that the industry is not there yet, but the commercial aspects of how to make money and when will this make money. And this is all of the optimization, route and flight optimization and yield and utility that we were talking about during this event. And then finally, a sustainability event. So for those of you who have been watching today and those of you looking towards seeing this on LinkedIn afterwards or on YouTube, also check out those events. I'm sure that they're going to be just as good as this one. And we highly look forward to welcoming you in the future. And to all of our great speakers, I couldn't thank you more. It was extremely interesting, touched on a lot of topics which are new for me and then some other ones which are very near to me. So on behalf of Lufthansa Systems and on behalf of the audience, thank you so much for bringing in your perspective, both sides of the Atlantic, and have a great afternoon or morning wherever you are.
Thank you very much.
Thanks, Erin.
Thank you.
Thank you, Erin.